BuidlGuidl DAO, and we are focused on developer education. In particular, we have this stack, Scaffold-ETH, and this curriculum, speedrunethereum.com. If you are interested in learning how to build on Ethereum, or you even have friends that are interested in building on Ethereum, tell them to go speedrun Ethereum. I see some familiar faces that were at the last sessions. It's a lot of the same similar content today. We're just going to start with Scaffold-ETH and build something simple, and then I'm going to hand it off to Kevin Jones, and he's going to do a like an extensions build, I think. So we're going to kind of try to wrap 2 sessions into one here. I'll do the intro to Scaffold-ETH, and then he'll do that extensions. And I think maybe we'll even have like a little Q&A, possibly in the middle of them too, while he's getting ready. So Scaffold-ETH is our stack of choice. And it's great for prototyping. Ooh, look at that. We still got our NFT up. I got to close stuff out here. Holy cow. Sorry. Boop, 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 boop. Boop, 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 boop. OK, here we go. So Scaffold-ETH, you can find it at scaffold-eth.io. It's a prototyping tool, but you can also push to production. It's good for tinkering, and we'll get into it here. So there's 2 ways to do it. You can kind of clone the repo, and that's kind of the old way to do it. And the new way to do it is with npx create ETH. And npx create ETH is sort of like the step toward our extension system. So we'll be using that mostly today. And yeah, I think just to level set real quick, I probably didn't introduce this very well. We're going to have like a whole day here. I think we're in this room like all day today, till like 6:30 tonight or 5:30 or something like that. So we're going to do introductory content right now. I'm just going to quickly show you how to build and ship an app. Then Kevin will do the extensions. Then I think we'll take a lunch break, and we'll come back and we'll build a few more things. And then we're going to have a CTF later today, so a capture the flag, where you actually have to like hack some contracts and mint some flags. So it's going to be a lot of fun. If you're more technical, the afternoon will be better. If you're just getting started, the morning will be better. I'm so sorry to all the people that I keep seeing at all these talks. You guys keep coming to my talks, and I keep doing the same builds. Like, I need to like innovate a little bit here. I try to do something a little different every time just to make it more interesting. But thank you guys for coming out and supporting. OK, let's go. Let's get Scaffold-ETH going here. So we're going to run npx create ETH, and it's going to be kind of like a little choose your own adventure here. It's going to take us through, let's see, this is DevCon app. I'm going to call it DevCon app 3, I think is where we're at right now. And this is kind of like one of our more controversial things. We kind of still have defaulted to hard hat. It's taking us a while to like really get Foundry the way we want in Scaffold-ETH. But you can choose between hard hat and Foundry's almost going to be the default soon. But it's up to you. You can choose either one. Both are good. Foundry, you're going to spend more time writing your tests in Solidity. And so if you're building just like a super complicated protocol, like Foundry's probably the option that you should take, because you're going to need to write lots of tests. And those tests run in Solidity. If you choose hard hat, it's a great option still. I think the deployments are a little smoother, and everything's in TypeScript. So I think hard hat leans a little bit more toward like the app builders. And they're doing a good job at like speeding up too. I think maybe one of the concerns was that Foundry was just a lot faster than hard hat, and I think they're improving a lot of those things. I just pick one randomly. I think I did hard hat for my DevCon app number 1, and I think I did Foundry for my DevCon app number 2, and I'm just randomly back to hard hat for DevCon app 3. But it doesn't matter whether you choose Foundry or hard hat, it's still going to be the same commands. We're going to do a yarn chain to bring up a chain. Yeah, what's up?
Which one did you say is more geared towards TypeScript?
That's hard hat. Hard hat is all your tests will run in TypeScript. So like when you build out a test bank in TypeScript, you know, go query this amount, make sure it's that amount, write to the contract and make sure it wrote correctly. You're going to be writing that in TypeScript. And so that makes it really nice if you're going to also be building an app, because you can get in and kind of copy that code right into your app. So if you're an app builder, sometimes writing those tests in TypeScript makes sense. But it seems like the GigaBrains are moving toward Solidity as a testing. You know what I'm saying? Like, I can tell that they're smarter than me and they know what they're doing, but I don't know exactly why, but they're onto something. So I think that like the Foundry and testing with Solidity is like the future and probably where we'll go. But as an app builder, I feel like I can relate with TypeScript and JavaScript more. And like I said, like when you can copy paste right into your app, it's really nice. Okay, so once everything is installed, and shout out to the organizers. This is cool. Like I've been to conferences before where I've done demos and the internet was not good enough to install this whole stack, and we just installed the whole stack just now. So shout out to Skylar and the team and the DevCon team, Nathan. Okay, and of course, all of you guys that are doing all the work behind the scenes. Okay, here we go. We're going to spin up our local blockchain. So like I said, whether you're using Hardhat or Foundry, it's the same command. With Scaffold-ETH, we kind of abstract it away a little bit and just give you the commands that you need. That command was yarn chain. So I ran a yarn chain, and that basically spins up my local blockchain. And then I can do a yarn deploy, and that's going to deploy the kind of like the template smart contract that comes with Scaffold-ETH. And then we're going to do a yarn start in another terminal here. So it's kind of like launching a rocket. You got a few things here. It feels overly complicated, but once you figure out that this is kind of like mixing two packages together, and you sort of have this back end that is the blockchain, and then you have the front end, which is like your Next.js, it starts to make sense how this works. And Scaffold-ETH particularly does a good job with taking your artifacts from your smart contract and injecting them into your front end. And I'll show that when we start writing the front end, it's really nice because it starts to give you hints and it knows everything about your contract already. Okay, so let's get into the code. I'm gonna use cursor or code. Whatever, if you guys use code, you just do code dot, right? But I like cursor. Even if I'm not using the AI feature, I just use it as my IDE most of the time. But it's really nice because it has this tab over here where you can pull it out and be like, yo, build some buttons, and GPT or Claude will just like inline write the code for you. So definitely, if you haven't checked out Cursor, go grab it. It's a great code IDE. Okay, so if we look at our packages, we have Hardhat, and then we have Next.js. Like I said, that's kind of like your back end and your front end. And if we get into Hardhat, we can find the contracts. Scaffold-ETH starts with this kind of generic contract that has a little bit of everything just to get you started. A lot of times you might just like carve it out, right? That's why we called it Scaffold-ETH. You kind of need the scaffolding, but then as you get the thing built that you want, you can kind of tear down some of the scaffolding. Ooh, I think my little mic is going weird. Okay, here we go. So let's get into this contract and look at it, and let's just tinker around. I think one of the first things to show off with Scaffold-ETH is just this kind of dev loop you'll get into. And let's look at that. Okay, so we've got some, let's look at this smart contract. Is that big enough? You guys can see that okay? Yeah, okay. So you've kind of got your primitive data types, whether you're tracking addresses or strings or bools or numbers. There's mappings between these primitive data types, like for any given address, you can keep track of a number, like a balance or something. Events, the constructor, even a modifier here, which is a little goofy. You can kind of get the syntax. I would recommend Solidity by example. If you are feeling like you need a little bit more help figuring out the syntax and just getting a little bit better at just writing your first few smart contracts, definitely check out Solidity by example and just like go through each of these examples and just copy paste them into Scaffold-ETH, and they're really great examples to learn from. Like for instance, like if we were going to go learn what a mapping is all about, we could get over here and we could copy this mapping and we could paste it into our smart contract and then go dink around with it, right? That's kind of like a good loop to get into. Let me specifically get to this contract and dink around with it, but I just wanted to show off Solidity by example as kind of a tangent here. Whenever you're writing your smart contract, if you're writing it yourself and not just prompting AI, you probably want to like go to Solidity by example and find some of these kind of nice copy-paste examples. But I'm going to close that out. We're going to go from memory here. Okay, so I want to look at this set greeting function. It looks like we pass in some greeting, a classic, greeting contract. This guy's kind of waving around. Am I okay here? There we go. Classic greeter contract. We're going to set some string. But this is the neat little code block that I want to test, basically. It's if you send money in when you set the greeting, it sets this little premium flag to true. And I think that's going to be what we'll do here in a second. Okay, so once we have our back end up and we have our front end up, let's go visit our app. Here it is. So Scaffold-ETH kind of comes with you're going to write some Solidity, and then you're going to have this debug tab. Here, let me make this a little wider. There we go. See that debug tab? There we go. This debug tab, and this is going to give you this really nice interface where you can kind of just point and click, try things out. You can poke at your contract. You can test your assumptions. So let's go look at that greeting contract. Let's go set the greeting, right? And that's going to teach us about burner wallets and ETH to Way, a couple of the initial concepts. Let's just try to set it. It's going to yell at us. So if I say hello world and I hit send, it's going to say something like you don't have any money. And so right up here, there's a nice little, when you're on localhost, it recognizes you're on localhost and it gives you a nice little faucet button. But as soon as you push this thing to a live network, that faucet will disappear. So I'm just going to click that, and that should give me some ETH, right? Now we've got some money to work with. Now the second thing I want to bring up is burner wallets. You'll notice there's a wallet here, and I could connect my MetaMask if I wanted. But when we're doing local development, when we're doing quick dev, I want to be able to just like hit a button and send this transaction. I want to just be able to click it and have it go, right? Did you see that? Like that was a transaction. There's a transaction. That's a transaction. That's a transaction. You get a transaction. You get a transaction. So it's just faster, and it's a lot easier to kind of test what you're doing, to not have MetaMask popping up and switching the chain ID and a bunch of other things that you'll run into. But this thing's all ready to go, so by the time we push this thing to a public network, we'll be able to bring MetaMask in and we'll be able to hide those burner wallets, but for now it works really good for dev. And let me just triple down on the burner wallet thing real quick. If I open up an incognito window and I go to localhost, see I get this account, this sort of 1A55. Let me do that again. Localhost, and it's a new account, right? Because it's in incognito and it's keeping the private key at local storage, you're getting a new one each time you bring up that incognito window, which is super nice for testing. And I'll show you that in a little bit. But basically, you could say you have this function that you only want the owner to be able to call. With these burner wallets, you can kind of bring up the good guy burner wallet, bring up the bad guy burner wallet, make sure the good guy can do the thing, make sure the bad guy can't do the thing. It's not like an exhaustive test, but it's a great way to quickly test your assumptions. Okay, here we go. Let's go. Hello world 3. That's what I'm, oh, whoops. Hello world 3, send it. Okay, so I want to get this premium flag. See over here, these are all the it's reading from our contract, all these different values. And there's this premium flag here that's still false. So what I want to do is send in some money, right? The contract is still empty. It doesn't have any money. What we're going to do is we're going to send in 0.001. And here's the next weird thing about building on blockchain is this whole idea of ETH versus Way. And again, Solidity by example has a really good Ether versus Way explainer here. And when you put a 1, so when I'm in a smart contract and I put, a 1 right here, that is 1 way, right? And so if I wanted to send 1 ETH, I need to send 1 times, oh, get out of here, 1 times 10 to the power of 18, right? That is 1 ETH. And the reason is the EVM is a super simple little computer. It doesn't want to mess around with floating point math. So you don't do decimals in Solidity. You have to basically do whole numbers. So sometimes when you need to do something like take a thing and add 5% to it, you can't just like multiply 1.05. You have to like do some like numerator denominator stuff. But the thing is right here, we have this little button, and it does that for you. Now, only would a developer need this. Like, once you start building your front end, you need to do the ETH to Way conversions all in the background, and the user should not know about it. You should just be like, I want to spend 0.01 ETH, go, and it goes, right? Or even better, the USD value of that 0.01 ETH, and then maybe the 0.01 ETH underneath it or something like that. But if I try to send this right now with a 0.01, it's going to give me like a big int error. It just doesn't like that, right? Developers need to remember, and this is why we put it into Scaffold-ETH, you have to hit this button and you have to take it times 10 to the 18, and then you hit send. And there we go. We made a transaction, and what I wanted to show off was if we send in money, it should set this premium flag to true. And it did. It's true now, right? And if we zero that out and send it again, does it zero? I don't even know. But we can test our assumptions. We can just try it and see what it does. Yep, so now premium goes back to false. Okay, so let's write a quick little smart contract app, and specifically I want to show you the sort of like core game loop that you'll get into with Scaffold-ETH, and that's basically, let's get out of here. You'll add something, right? Like, what do we want to build? Do we want to build, I like the idea of the beneficiary. That one, I've got this like prediction, like simple prediction market that I want to build, but I haven't like fully thought it out, and I don't think I should just figure it out on stage. So I think what I want to do is do like a beneficiary and set it up so the beneficiary receives some money, and we have like a little front end where we can update the beneficiary. Just set something in a smart contract, and that whoever that beneficiary is will make the money. Okay, so we're going to have a public address oh, look at that, thank you. Beneficiary, okay, and it's set to the 0 address right now. If I were to deploy this, it's going to be the 0 app that is the beneficiary, but we do have a beneficiary now, but it's the 0 address, right? So let's start that off with, I think I'm going to do, let's go to address vision, atg.eth. I want to make this guy the beneficiary. Yeah, that dude right there, okay? And then I'm going to paste that into the contract right here. There we go. Okay, so now we have this beneficiary, and we're going to need probably some function that lets us set the beneficiary. And let's make that, we have this owner. I don't know. We're just going to make this public. So this is another thing I do sometimes when I do these demos is I make a very insecure app and deploy it to production, and I think I'm probably going to do that here. Basically, I'm going to let anyone set the beneficiary, and then I could delete all this stuff probably, but I'm mostly going to leave it. But there's this withdraw function here, and in this withdraw function, only the owner can withdraw the funds, and I don't want to do only owner, actually. I want to kind of get rid of this idea of the owner, and I want to require beneficiary. There we go. Man, Copilot is on point. All right, so, and then I want the beneficiary to get the money. Okay? And let's go test it out, right? Like I just made some changes to the code, and like this is a smart contract that's going to be moving money around, and I want to be a little bit more confident that I did the right thing there. So that's what this like core loop is about, is like testing those assumptions. I've said that so many times. I need to come up with a new phrase. But let's go set the beneficiary to, now watch this. Scaffold-ETH has these components out of the box, like this address input field, which are really nice because they do ENS resolution, ENS avatars, you got the blocky, you have the address. But let's see what happens there. Okay, I was able to set Vitalik as the beneficiary, and I think I can set anyone here, right? I can do atg.eth and hit send. Basically, anyone can set anyone as the beneficiary, and then whoever is the beneficiary, let's set this dude to the beneficiary for some reason. Send. Now, someone should be able to hit withdraw and pull the money out, right? So let's say a bunch of people came in here and said, hello world, and they paid 0.01, and they hit the button and they send it, right? And now the smart contract actually has money in it, right? There's $32 sitting in that smart contract now, and we just want the beneficiary to be able to get in here and hit withdraw, and we want to make sure that money disappears and shows up over here. I didn't watch very closely, but I'm going to assume, no, let's not assume. Let's figure it out. Let's prove it real quick. Let's set another greeting, send some more money in. So we're at 988, I'm gonna reload that. All right, 9882. Now if I withdraw, I'm watching here, what, like that decimal right there, right? We gotta make sure that, yeah, 99, okay, good. So this is not an exhaustive test, right? You want to build a whole test bank to make sure this thing does what it needs to do, and there aren't any weird edge cases where you're going to lose money or get money locked up. But in terms of our little smart contract, I now am able to like keep track of some beneficiary, and anyone in the world could set that beneficiary. And when they come in, only the beneficiary is able to withdraw the money, and it goes to them. It's a simple little app. You guys are the Solidity developers. You'll spend more time building things. I'm going to build a silly little example, but you're deploying an always-on app that will last forever, possibly longer than you, and it's nation-state level hardness. So don't get thrown off by my silly little examples. Like there's world-changing tech here, and sorry for my simple examples, but we're just going to build like this little beneficiary system. Okay, so it's sort of working. It does what we need it to do. I can set the beneficiary. There's some other functions here that I'm just going to leave. The beneficiary can do the withdraw. What I want to do now is go start working on the front end. So just to recap, the beginning of this is about tinkering with your smart contract and putting in some solidity here, and then testing it out over here in Scaffold-ETH, in this front end in the debug contracts tab. And you'll do that for a lot longer than I did. I'm kind of like time boxed here to a short window, but you'll get in this mode of tinkering with solidity and getting things right here, and that will take longer, of course. But once you've got it, and let's just pretend I do. Let's pretend that I have built my whole app, I've tested it, it works great, it's very secure, I'm about to put it on a blockchain forever, and it's awesome. I'm gonna actually take this import out too. I hate deploying that on chain and paying for it. Let me take that out here. There's some nice console log debugging you can do with Hardhat, and that'll spit out over here. Whenever there's a console log in your code, you'll see it over here in your blockchain, and really nice for debugging, especially when you're like, why isn't this decimal working? I thought I could do that, yeah. Okay, I just wanted to take that out and redeploy. Let's see if everything's happy here. Okay, we're happy. So you'll spend more time on your smart contract. I just did a quick smart contract. Let's pretend that it's all good to go. Now we're thinking about our front end. What do we want? We have this beneficiary, and we can set the beneficiary, and we can withdraw. I think I want some kind of front end that lets me put in an address and set the beneficiary, and then another address, and then another button underneath that lets me like withdraw the money or something like that. So we're going to read and write from the chain in our front end, and let's go start working on that. So this is kind of phase 2. Your contract is pretty solid. You may come back to your contract and add some events in, maybe add some read functions, but generally the functionality is working, you're good to go. So most of the time now we're gonna be over here in React land. And normally I would definitely just prompt GPT. I would not be writing this code, but I feel like that's kind of like lazy. Like, I don't think it's, it feels weird to be prompting GPT in front of 30, 40, 50 people and be like, bro, please, full files only. Like, I feel like that is a weird experience to do in front of a bunch of people, so it still makes sense for me to maybe just like live code this thing rather than ask GPT. But if I was at home and it was just me, I would be yelling at the GPT to get it to work and not actually writing my components myself, but we're gonna write them ourselves. And we're not actually gonna write them ourselves. I'm gonna go to the docs and I'm gonna copy paste. So Scaffold-ETH, we go to the docs, there's this tab over here called interacting with your contracts. And there's external contracts too, but interacting with your contracts is kind of the first thing. And here it is. Here's how you read from your contract, and here's how you write to your contract. And this is using WAGMI, so you could always use WAGMI from VM and look at their docs and go learn some things. We've wrapped it slightly because Scaffold-ETH handles some wallet stuff and other things, so it's using the use read contract from WAGMI, but we called our own function use scaffold read. It takes a couple less arguments, and we fill those things in for you. It's a simple piece of abstraction, but we think it's the right move. Okay, so what we want to do is read from our contract. We have this smart contract that's keeping track of this beneficiary, and I want to display the beneficiary on my page, okay? And so far, all we have is the connected address. Oh, shoot, I gotta go show the page. So we've been on debug contracts the whole time, but if I hit home here, this is gonna take me back to the page, and I've cleaned out all the stuff that was here, so now it's just down to this. And let's see, welcome to, this is going to be called, I don't know, DevCon app 3, con app 3, the beneficiary, oh man, I didn't spell it right. Come on, help me. A-R-Y, did I get it? Oh, there we go, thank you. Okay, and now that should change over here. There we go, okay. And it's showing us our connected address, has that little blocking and everything, but now what we want to do is read who the beneficiary is from the smart contract. And I've got that piece of code copied already, so I'm going to bring it in right here and paste. Okay, so this is where I was talking about. It's really nice because Scaffold-ETH knows about your contracts. So as soon as I hit one of these buttons here, let's see, I think I just opened the quotes maybe. It's going to start, it's not. Which button is it? It should auto-complete to whatever the value is in the contract. Something is not right. Let's see. Oh, we need to import it. Here we go. Let's try that. Is that what's happening? Basically, when I open this quote, it should give me, there we go, that's what I want. So this little list is the stuff from my smart contract. So as I'm banging away on that Solidity and I write out my smart contract, it knows about all that stuff, and it can set it here. So instead of going to the smart contract and being like, what's that variable I want to read, I'm kind of in line just like, oh, I'm going to your contract, and then I want the beneficiary. And I don't think there's any arguments. And let's hit save, and then we want to name it beneficiary. Okay, and it's yellow because we're not using it yet, but let's go down here and put a div. Ooh, what was that? I like that. Yeah, okay, but I don't want to use the address component yet. I want to show it off raw first, and then it will help us understand what we want to do next. Okay, so now we should be reading from our smart contract, whoever that address is that is the beneficiary, and we should be displaying it right down here. Let's go look and see how that looks. Ooh, looks good, right? Almost. It's working, it's displaying the beneficiary, but this is kind of a gross, it's kind of like a full address, a full hex address, kind of ugly looking. What you'd like to do is do ENS resolution and a lot of things like that. So what you do is, instead of just doing beneficiary like this, you wrap it in an address component. And this address component comes out of the box with Scaffold-ETH. There's an address and an address input and a few others, and I can show you in the docs where to find those. If you go to components here, there's all those handy components. And to extend that, we have an extension system that uses a lot of other components, like the on-chain kit from Base. So if you wanted like a swap component, you could use the extension system to bring in the on-chain kit and just add that in too. So we have like low-level components, and then the extension system will have like some nicer level components. And Kevin Jones will show that off here in a little bit when I get done speed running this. Okay, so how is our front end looking? Let's go. We have, oh, doesn't that look so much nicer? Let's do that again. So, whoops. So this is like at the eye doctor, you know, number 1 or number 2? Number 1, number 2. Doesn't that just look gross? And then when we do just this quick change and we hit save, and this looks so much nicer. I love it. Okay, so we're displaying who the beneficiary is, and we know who the connected address is. And then, okay, now we need to, let's see, we want to write to the chain. And I think maybe we could, maybe let's just make a withdraw button first. I think that's the move. That's the move. So let's go back to Scaffold-ETH docs. So now we want to write to our contract. We're able to read from our contract, but now we want to write to our contract. So what you do is you set up this like async contract writer, and that goes in with your hooks there, okay? And that's going to talk to our contract. It's already named your contract. Ooh, we need to install it. Okay. And then write your contract async. Okay, so we've got this object now that we can write to. So then here is a button. I'm going to copy that button exactly, and I'm just going to use it. And let's go down here, maybe set up like some divs. Let's do a div first. There we go. Then the button. Then hit save. Okay, so what is this doing? It's writing to the contract, and it's calling set greeting. So we don't want to do the greeting, though. What do we want to do? We want to call what? I don't even know what. Set beneficiary, set greeting, withdraw. I think we want withdraw. Let's go with withdraw. Okay. And then there's no arguments or value. I think I can trash both of those. And let's see, call this withdraw and hit save. And let's see if we have a button in our app now. Oh, get out of here. Yeah, cool, now we have a withdraw button. Man, my front ends are so ugly. Scaffold-ETH does as good as it can to like make this look nice, but I just tear it up and it looks terrible. Okay, can I hit withdraw here? It can't because I'm not the beneficiary, right? Because Austin Griffith is the beneficiary. I need to set this dude as the beneficiary. And we'll make some front end to do this, but let's just go do it in the debug tab real quick just to test that this withdraw function works. Yep, it does. Okay, cool. So now we're reading and writing from our smart contract, right? We kind of tinkered around with our smart contract in phase 1, and we kind of built the app that we wanted to build in terms of the solidity. Like I said, you might come back and add some events, but you're pretty much done there. Then we kind of move over in the front-end land, and we start tinkering with how we want our front-end to look. We've read the beneficiary from the smart contract. We've used WAGME to tell us who the connected address is. And then we've written to the chain with this nice withdraw button here. So the last thing I want to add here is a little address input field that lets you put in a new beneficiary and save them. And I think, let's see, how am I going to do this? Maybe down here. Let's just make another div down here. It's kind of weird. Let's see. I want an address. I'm just going to go copy paste it from the docs. Just go copy paste it. Here we go. Normally, I would prompt the AI with like examples and just have it write it all for me. But let's do it this way. I want address input. Okay. So I want to grab this. Okay, it looks like there's a state. Oh yeah, yep, I want all that. I want that right there. So you have some kind of state over here. Boop. And then you have your address input right here. On change, it'll set the address. Okay, let's see how this looks. Do I need to install this? Yes, I think I do. Let's see how we're looking. Let's see what our app looks like now. Uh-oh, use state. We've got use state is not defined. We need to go to that use state from React and make sure we import that. Oh. Open Apple period. There we go. React. Bring it in. Let's go. Let's go. All right, how's our app looking now? Ooh, there we go. Okay. Ooh, there's a semicolon floating around there. I don't know what that is. I'll go get it in a second. But now you should be able to type in Vitalik.eth, and you should get that nice ENS preview. You should get, boy, I need some padding. This app looks terrible. How do I do that? Maybe some like class name. Yeah, ooh, we might even center the div. What does that do? Oh, wow. Yeah. Okay, let's get rid of that weird semicolon too. I don't know where that's coming from. Right here. We don't need that. Okay, and I kind of like this class right here. I'm going to bring that and I'm going to give that to all these other divs just so this thing starts looking a little bit better. One for you. One for, maybe we do, let's do a div here and do that class name. Yeah. And then close the div here. Oh, I think it tried to close it for me. The AI can just write code better than I can. I shouldn't be doing this. There we go. Doesn't that look nice? We need a little padding, but I'm gonna go with it. Boy, this is a really ugly front end. Okay, so we have the withdraw. That's working. We have the address input. That's working. It's tracked in state. I think what we need to do is one more write function where we set the beneficiary. So we're going to need one more write function. I'm just going to copy paste. Actually, that's all good. I can just use that write async. So let's go get another button from the docs. Oh, here, I have it right here. I'll just copy this button here. Right, this dude. Okay, and I'll take the whole div. Okay, and we're going to put another button underneath this, and this is going to set the beneficiary. And then for the function we need set beneficiary, and there we go. It wants to give us some args. That's what we want. Is address the thing that we're keeping in the state? It is. Okay, I think we might be happy. Let's see what we have here. Okay, well, it looks ugly, but let's see. Can we set Vitalik as the beneficiary? Boy, a little padding would go a long ways there. Yeah, it worked, right? Now Vitalik is the beneficiary. All right, let's try that again. atg.eth, set him as the beneficiary. There it is. Okay, so it's working. All right. And then if you are the beneficiary, like this dude is, then once that updates to that, you should be able to hit withdraw, and that should work. But if you're not, let's go back and do atg.eth again, set him. Now if I hit withdraw, it should fail, right? Because I'm using the burner wallet. Yep, not the beneficiary. Okay, cool. just want a little padding here. It's just driving me nuts. Let's see, P, yeah, there we go. There and there. How's that look? Yeah, it's a little better. It's still ugly. Okay, and another thing we might do is only display the withdraw button if the connected address is the beneficiary. Like, we should probably only show this withdraw button if these two are the same address. And here's a great chance to just prompt the GPT to do this. But we could say something like, please only show the withdraw button if, let's see, what do we have? If beneficiary is equal to connected address, right? There we go. Let's go. Yeah, thank you. And then it's just going to give us the code, and we apply that and save, and let's go see now. Let's test it out. Okay, so it looks like that withdraw button is gone now. That's okay. But if we set us to the beneficiary, does the withdraw button come back? That's what we want to test. Yes, it does. All right, GPT, you got on the first try. Thanks, bro. All right, awesome. So this is kind of, we're nearing the end of phase 2. Basically, in phase 1, we worked on our smart contract, we tinkered with it, we went back and forth, we got our solidity right. In phase 2, we did a lot more React, kind of getting our buttons, things wired up, we're reading and writing from our smart contract. Phase 3 is now deploying. We want to put this thing out into the world. And to do that, we'll have to deploy both the smart contract and the front end. So to do that, we're going to need to yarn generate. And yarn generate will create a deployer account. So you want to be very careful with these deployer accounts. You really don't want to be like copy pasting private keys around. They really should be like living encrypted on your box. So when we generate this account, this is like a one-time use account basically. Like this account should only ever have enough money in it for me to deploy this contract once or twice. So there's my address. Then I'm going to do yarn account to show it. Okay, there we go. And now I'm going to send some money in there, and we're going to put this thing on a live blockchain. Let's go. Okay, let's see. I'm going to use a Punk wallet app built with Scaffold-ETH. Let's see, we had it on Optimism yesterday. Base, let's see if I have any Base in here. I think I'm going to deploy this to Base. Okay, so I just select Base. I scan my QR code. And I'm going to throw $1 at it, right? It should be enough. Shouldn't be too expensive. Ooh, time to retweet Shutterblock. I got you. Yeah, let's go. Retweeting on stage. Okay, so hopefully I just sent some money here. Actually, yeah, I did. Okay, let's do yarn account, and it'll even like give us our balances on the different accounts. And is Base in there somewhere? Localhost, Arbitrum. Let's just see. We're hoping I have some Base in here somewhere. There's only, oh, there it is. Yep, we got some. We have 0.0003 ETH, okay? So we've created a one-time use deployer account. We've put $1 in it, and now I'm going to do a yarn deploy just like I was before, but instead of yarn deploying locally, I'm now going to do the -- network, and I'm going to go with Base this time. Now hopefully this works, but let's see if it complains about anything. We may just put a smart contract out on a live network. That's looking pretty good, y'all. Okay, cool. So our app, though, still says hard hat up here. We need to get in and change our app over to Base. And what that means is the whole app is going to change networks. So right now, if I click on this dude's address, it's going to take me to a local block explorer, which is cool and nice for local debugging. But this is also really awesome. As soon as I set this thing to Base, then all of my address components all throughout the app will now link to the Base scan block explorer. Let's do that real quick. So I'm going to hit OpenAppleP and find the scaffold config. And from the scaffold config, I'm going to change it right here. And you can even do like a comma-separated list here. You can have multiple networks. Like you could deploy your smart contract to Optimism and Base and let your users pick which one they want to use even. It's pretty nice. But we're just going to go with Base. Now watch this. As soon as I hit save here, the whole app now switches over to Base. And it doesn't let me use burner wallets anymore. And that faucet is gone, right? By just setting that one thing from localhost to Base, your app now knows that it's like, oh, it's time to sit at the big kids table. We're going to go use like our real wallets and real money here. And let's do that. Okay. Yes. There we go. Okay. So we are now talking to our live contract on Base, but we're still at localhost. So a second step that we'll get to in just a second will be to deploy the app live to Vercel. But first, let's just tinker around and make sure everything's working on-chain correctly. So let's see. Can we set Vitalik to the beneficiary real quick just to prove that we can? And I'm actually going to pay real money to do this, right? I'm going to pay like, a fraction of a penny. No, more like 32 cents. Dang. Whew. There we go. And now, hopefully, Vitalik will become the beneficiary. I'm going to hit reload. I'm impatient. There we go. Cool. And it's working. Okay. And our withdraw button disappears too. Looks pretty good. Okay. So then let's, I don't know. Let's set me back to the beneficiary. And then maybe let's put some money in the contract and then withdraw from it. Make sure everything's pretty solid, and then we'll ship our app. You know what? Actually, I'm going to start shipping the app now because it takes some time. So kind of the commands, if we go through the whole stack of commands here, we did yarn install, yarn chain, yarn start. To get your account, we do yarn generate and then yarn account. And here we're going to do yarn. This is the best command out of all of them. Vercel YOLO -- prod. Like, please, do not check anything. Just ship it. And that's what we're going to go with here. Yes. Got to do the choose your own adventure here of like picking the scope and the account and all that. Ooh, it's very slow. No. DevCon 3. Okay, so that will take a couple of minutes to ship, but now that it's shipping, it's nice because we can go back and tinker around with these few mechanics that we were worried about here. So can I set me back to the beneficiary, basically take control back of the contract, and then let's maybe even send some money into it, right? Let's do a greeting that says, hello, DevCon. Nope, I'm gonna do hearts, 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 classic. Hello, DevCon, hearts, 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 and I'm going to send in some money. And technically, this money could be stolen. Like, anybody out there could go to the smart contract, set themselves at the beneficiary, and hit withdraw. I don't think they'll do that, but maybe they will. Let's find out what happens. Okay, yeah, $3 to be had if you want to steal it. You'd have to go find the thing out on BaseScan or something like that, right? Like if we go look at the contract here, it's probably not even verified yet. But remember that contract component, all I have to do is click here, and it takes me right to the BaseScan, right? The correct block explorer for whatever chain you're on. And here is the smart contract, but it is not verified yet. Yep. Okay, so I would need to verify the contract before anybody is probably going to attack it. I don't think anybody is going to figure out how to attack it right now, except for maybe you guys out here, which kind of have the alpha on it. So please come steal it. Like, I would happily lose my $3 to anyone in here who wants to steal it, because that means you guys are way ahead of the game and really paying attention. Let's go here. DevCon, hearts, hearts, hearts. We got money in here. Nope, I need to hit send here. Wait. Didn't I hit send there? Why isn't there any money in here? Let's reload this real quick. Okay, maybe I didn't hit send. I wasn't paying attention. Let's try one more time. DevCon. No, it's right there. It's right there. Hearts, hearts, hearts. Premium is true. Oh, man. What if someone already stole the money? Like, it's not in the contract. What? Yeah, someone did. Look at that. Look at this address. This is not my address. This is someone else's address. Someone got in and got it right away. Wow, that's really impressive. That's neat. Okay, well, someone stole my $3. All right, all right. That's pretty awesome, to be honest. Like, that's really cool. So that's like probably like a bot that's like watching for contracts to get deployed and looking at the bytecode, and man, that's really cool. I don't even, that's so cool. Like, I'm like thinking about how, like, we could definitely defend this, right? We could set up a require statement here that says only, certain people could set the beneficiary. There is this idea of this owner, and we could say the owner is the only one that can set the beneficiary. Let's just do that. Let's just do that. All right, so we learned a lesson here about the dark forest. Okay, so, you know what? I don't care. No, we're shipping it. This is more fun like this. Let's just leave it how it is. The app is going. Everything is good. Kudos to whoever's running that bot and taking my $3. I'm probably going to send them a couple more bucks here for a little bit. But check this out. So now our app is live. And you can go to Vercel and set up a domain on this thing. So within 30 minutes, you can kind of roughly crank out a smart contract, get a front end going, and then deploy the thing, not just to base, but also to Vercel. And there is a live URL. So yeah, within 30 minutes, we kind of built this whole app, and I'm going to go donate another $3 to this attacker just because, I don't know, that's pretty cool. Let's see, what are they doing? Let's go look at this address real quick. Look at all those zeros. Oh, this is definitely some nerd. They have, how many is that? That is impressive. Yeah, it's like an MEV bot that has a bunch of leading zeros. That is so cool. Oh, it's a contract. We can even go dink around with it. Ooh, maybe not. Okay, anyways, let's set the beneficiary back to atg.eth, and let's see if it like front runs me or what it does. That is so cool. Here, I don't know why I have to keep hitting this. I don't know if I need to like hard code the gas limit or something. MetaMask is just not happy with me with gas. Okay. And now, hopefully, I am the beneficiary. And it shouldn't steal it right now, right? Like, there's no financial incentive for them to set themselves as a beneficiary right now. What they want to do is wait until there's money in the contract, and then almost like in a batch transaction, set themselves as the beneficiary and sweep the money all in one transaction atomically. And basically, like, you only do that if you, Portman! You only do that if you, can make the money, right? So the MEV bot is probably sitting there like, we're going to do all of these transactions, and we're only going to execute them if it works and we make money. And if anything else goes wrong or we don't make any money, don't do it, right? So as soon as I put money in here, it's going to disappear again, which is pretty cool, but not great, but pretty neat. Let's see. Really, I feel like we could, if a bot is that sophisticated, I might like start making this as part of my like curriculum, where actually you like know that a bot is going to handle something for you, and you can have them like be like rolling the dice for you in some game or something like that. I'm gonna think about that. Okay, here we go. Please take my money, Mr. All. Oh, it could be Mrs. too. Yeah, right. I'm gonna say Miss Merce, all zeros. All right. Right. It needs to be, right. So it's costing about 30 cents to set the beneficiary, right? So then another transaction, maybe 60 cents. Like, it's got to be, within like $1 or something. We did 0.0001 last time, I think, and that was enough. Maybe we do 0.5 just to see. Let's see what this does. It would be really funny to like calculate it just right and see like at what point the bot takes over. But yeah, here I go. I'm going to donate another couple bucks to this bot, probably. Okay, let's see. There's the transaction. And does the money stay in the contract or not? Let's see. I'm assuming it will be immediately swept if, yep, they're the beneficiary already. That is so cool. Oh man, I'm going to use this for something. That is neat. Okay, so this is kind of the stack. This is Scaffold-ETH. This is how you can get started building apps. This is the way you would go about tinkering with Solidity. Kind of in our first phase, we used Solidity by example. We wrote the Solidity how we thought we wanted it. We left it very, very accessible and attackable. But you'll do a better job of that when you're building real contracts. Don't do what I do. Build a good contract in phase 1, and then in phase 2, we kind of built out the front end, and then in phase 3, we deployed the whole thing. So now, I think I'm going to hand it over to Kevin Jones to show off extensions in a little bit. But let me just like pause here just to see if there's any questions. Maybe we could do like 4 minutes of by 4 minutes. A couple minutes of Q&A. If anybody has any quick questions, and in the meantime, I'll hand it over to Kevin Jones, and he can do the same thing, but he's going to use an extension system, probably Graph or on-chain. Graph? Yeah, that's what. got to chill. Okay, any quick questions? Yep.
What was the command to deploy it? Can you show it again, the yarn?
The yarn command to deploy? It was yarn deploy -- network base. Oh, the Vercel. Oh, yeah. Okay, yeah. And also, this is in the docs, but it's Vercel. It's yarn Vercel : YOLO space -- prod. And that's what shipped the app to Vercel. Yep.
Before when you said you compiled it, you said wasn't verified yet, it sounded like you thought that would make it so it's not.
Yeah, I did. I'm pretty impressed. That means that someone is watching base for contracts to get deployed, they're decompiling the bytecode, and they're looking for attack vectors where they can make money, and they're even doing this like batch transaction. Let's go see if he batched the transaction or not. It could. Let's see, where is it? Yes, you do. So, so when you deploy a smart contract to any live network, the code isn't out there yet. You have to go to the block explorer and upload your code, and then on their side, they compile it and make sure it compiles to the same thing, and then they display the code. So if I were to go look at like WETH, say it one more time? The block explorer needs to, so see how this contract has like the green check, and we can get in there and actually like see the code for what WETH, how it works. Yep. So they have to verify, right? Because like they couldn't trust you to do the verification. You can send any code to them, but it has to compile down to the exact bytecode that's on chain for them to display that code up here. Does that make sense? It's not free, I don't think. It's just like a really nice cloud hosting service. I think it's probably less decentralized. We're a bunch of cypherpunks here, and Vercel is great for quick front ends. You can even this code is all open source and forkable. So if anybody wanted this code or to dink around with it, they could just deploy their own front end if they wanted. So like you could create infinite copies of this front end. So to me, it's like good enough decentralized, but also like you probably want to, if you're hardcore about this, deploy your site to IPFS also and have it live in some kind of distributed storage that people can access without, even if Vercel goes down, you can have that stuff pinned in IPFS. But yes, Vercel is a hosting service. I think we pay for it. BuidlGuidl has a paid account, but you can get started probably pretty cheap. Lots of guys can answer that question better than I can here too. We'll have a whole day of BuidlGuidl people here, so just come hang out and ask them some more, and we can show you around for sure. Okay, any last questions before I hand it off to Kevin Jones? I'll be up here again after lunch, and we're going to do Speedrun Ethereum. We'll go through your first 5 apps on Ethereum. Yeah, what was your question? There is a verify command, but I think you have to have your API key, and I don't want to go digging through my credentials right now, but if I do yarn, let me try it. Yarn verify -- network base. Let's just see what happens here. My guess is it's going to say you need an API key. Yep, I think so. There probably is some base scan API that I need to put into my config, but I don't want to go digging through that right now and expose a key in front of everyone. But yeah, I think yarn verify probably without even anything on the network. Yeah, it's not going to work. Yeah, this is trying to do it locally. But yes, yarn verify is the command. Okay. How you guys feeling? Feeling good? You want to go? Let's go. All right. All right, thank you all. I'll be back in a little bit. We'll be in this room all day today. This afternoon, we're going to be playing a CTF, Capture the Flag. It's going to be awesome, highly technical. We're going to give away prizes, probably like thousands of dollars, $1,000. We're going to also give away a node. We have a pre-synced BuidlGuidl node. So if you go to client.buildguild.com, we've made our own BuidlGuidl client. It actually runs Geth and Lighthouse. And these exist kind of all around the world, and it's like this opt-in system where you can become a distributed RPC for BuidlGuidl. But we're going to be giving some of these away. So you can get a box from us and take it home and plug it in, and it's going to look like this. It's going to have Reth and Lighthouse syncing automatically and lots of nerdy desktop stuff. Okay, thank you very much. We'll be here all day.
Thank you so much. Oh. Hello, welcome. Can you guys hear me okay? Yeah? Seems a little low, but that's all right. All right, cool. Thank you guys so much. My name is Kevin Jones. I actually work in DevRel for the Graph, so I work on the Graph protocol, which is totally appropriate because I'm going to show you guys the Graph extension for Scaffold-ETH and talk a little bit about the extensions. I'm also a core member of the BuidlGuidl, do a lot of workshops with the rest of the crew here. And yeah, so that was an awesome workshop by Austin. He covered really all the basics of Scaffold-ETH, so I won't focus too much on that, but we will talk specifically about some stuff that's on the actual doc site. So if we go to the docs, there's a section here for extensions. So you can come there. It gives you some basically like kind of overview of what the extensions is. You can have like a GitHub repo with the extension configuration, and then you can just execute it with this -e flag. And so there's a lot of like community extensions. If you go to, I think it's the BuidlGuidl website. So if you go to BuidlGuidl.com and you kind of scroll down a little bit, there's a section here, at least there used to be. Maybe it's on the Scaffold-ETH website actually, let's see. Yeah, here it is. So Scaffold-ETH, there's a whole area here where like check out available extensions. And we did a hackathon, I think, not too long ago. So there's a lot of really cool ones that have been built. The very first one was the subgraph one, which is really cool. It's basically got a, Scaffold-ETH, one of the cool things about it is it's this very local development kind of environment where you're just like able to hack away without pushing anything to a testnet. And so the subgraph extension is exactly that as well. We actually can spin up a virtual infrastructure of the graph on our machine, test our subgraph configurations just all locally using Hardhat. So we're going to show it off and show what it looks like. But there's a bunch in here, right? There's one for Ponder, if you prefer that. And then there's like ERC20. As Austin said, there's the on-chain kit, which is cool. It's got a swap extension. So yeah, and you could write your own. We'd love for people to build on that. If you go back to the docs and you go to extensions, there's a list of all the available extensions that we supported building, that the BuidlGuidl has supported. But you can also get the list from the Scaffold-ETH website. And then here, there's an explanation of how you create your own. So I personally have never created my own. It's definitely on my to-do list, but I think it's pretty easy. I think it's very similar to how you create a package with the npx command. You can also do that using this extension development utility. So you can come in here. You can either clone the repository, so you do need to clone the repository, which it's a special branch here. It's under the same Scaffold-ETH account, but it's called create-eth. So you can clone that create-eth package, install all the dependencies, and then run this kind of like build script. And then there's a CLI that allows you to create new extensions. So the subgraph extension, or the extension system is really cool. It really allows you to kind of make these custom reusable environments, all built around Scaffold-ETH, right? So let's just take a look at the graph one. So it used to be that we would have like a special branch of Scaffold-ETH, but we're moving away from that model, right? We're moving to this extension model, which was designed by the core BuidlGuidl team. And it's, basically this create ETH extensions repository. So you can think of it this way. There's the create ETH package, which is the way that you install Scaffold-ETH with NPX, right? But then there's the create ETH extensions, which is like if you want to build your own supported extension in the BuidlGuidl community, you might do that. So we have all of our ones that we worked on here. And the very first one, again, was the subgraph extension. So if we come here and go to the branch and choose subgraph, there's this nice README that kind of explains it, right? This is a README I wrote, which kind of shows you exactly how to set it up. So anyone who wants to follow along can do this, but I'm going to actually spin it up and show you guys how it works. Show of hands here. Who is hacking at the hackathon? A few of you? Just a few, huh? Okay. So, there is a graph bounty. So one of the things I always tell people is you could qualify for the bounty with this package and use it as kind of like a good starting point. Who here has used the graph before? Who has created a subgraph? A few of you guys? A few of you? Who here knows what the graph does? A few of you? Some people from the graph are here, which is great. Well, let me kind of preface it this way first real quick, because I think it makes sense just to understand the context. This is not a talk about the graph, but it makes sense to why we would use this graph extension. Scaffold-ETH is like this, right? It's got a front end, it's got a back end, it's got all this cool boilerplate code written, it's got these, all the proper packages you need to build and create a package or an app pretty rapidly. And it's really the quintessential way that applications on Ethereum have been written pretty much since inception. But there's kind of like this missing gap when it comes to reading data from the blockchain. Now, Scaffold-ETH is really good. It has these really cool hooks and be able to get the data that you need, just if you want to read it directly from the RPC provider. But if you want to get lots of data, if you're building a DeFi application or if you're building something like an NFT platform with lots of users, the more users you have, the more scalable your data issue is. So using something like the graph is kind of like a solution to that problem. So you can think of it like this. We're still going to use Scaffold-ETH, but we're going to use Next.js and Hardhat, and then in the middle, we're going to have this kind of graph infrastructure. So we're going to simulate this all inside of Docker. So the only difference here is we're still using all the packages that Austin used, but we have a layer that's going to run in Docker. So let's just spin it up so you guys can see. This is how you do it. So you just do npx create-eth at latest. And so we do npx create-eth at latest -e subgraph. So same kind of method. We just use the npx create-eth command, asks us what we want. What? My internet connection locked up. Did I do something? Uh-huh. Like a VPN? Oh, tether. Oh, I see what you're saying. I have a tether. Yeah, let's do this. Let's just try VPN. Almost got disrupted right now. That was very scary. I was like, I've never seen that error before. Okay, cool. So it's working now. Thank you so much. See, BuidlGuidl homies got my back. All right, so it's going to do the same thing. It's going to give you this kind of choose your own adventure method, right? So we're going to do, I don't know, devcon, sure. Hit enter, and same thing. We get to choose a package. We support both. I personally like Hardhat just because it's been around for a while, and I'm just so used to writing this stuff in TypeScript. But you might choose Foundry, like Austin said, if you want to write solidity tests. That's the way to go. Or you might just not use the chain at all. Maybe you just want to use the graph for doing some data stuff. You could do that as well. So it's going to go through, install the packages for us. Again, it's going to scaffold out an environment. Now, Austin mentioned that Scaffold-ETH is this kind of mono repo, right? It's got the Hardhat or the Foundry, and then it's got the Next.js package. Well, this is just going to give us one additional package, right? It's going to give us this additional folder called subgraph, right? And it's going to lend that by going through and basically using, this, where is it? Right here. Using all the boilerplate code that comes in here. So if we go to extension and we go to packages and we go under there, you'll see that there's this new subgraph folder, right? So let's give it a second. On VPN, it's probably even a little bit slower. I'm using a cool tool called tmux, just lets me split my screen up. This doesn't obviously need to be that way. We can just do that in different windows, but let's do that. So devcon, cd devcon, okay, cool. And while that's loading up, let's just take a look at the code, because it should at least be there for the most part. Okay, so we see this packages folder, and then we see there's an additional folder. So in this case, we have this cool extension that we can use called subgraph. We can go in there, and we can start to see what's available to us. So it's the same exact thing for Scaffold-ETH. We have the contracts folder. We have the same exact sample contract. And then on top of that, we have the Next.js folder with the same exact code. The difference is we also have templated in some cool additional code. So an example would be, like in this case, we wanted to have this like subgraph route. So Scaffold-ETH uses the app router functionality of Next.js. So we have this subgraph folder. And then inside of there, we have this dedicated folder or this dedicated page with all of the code for the front end. And you'll see what this looks like in a sec as soon as it's done installing the packages. It's a little slow right now. And then let's take a look at the graph. So without doing a full overview of the graph, I just want to kind of explain, like within a few words, what a subgraph is. A subgraph is really just an API, right? It's basically an API layer for any kind of blockchain data, right? It's this middleware layer. And so we basically want to create what are called subgraphs to organize the data. So just like we have a contract here called your contract, and we have this concept of updating the greeting, which Austin showed off, right? Where you can like update the greeting, pay some gas, pay some value. That greeting has an event, right? So it has this basic event. So that event says who set the greeting, what the greeting was, whether they paid some value or not, true or false, and then what that actual value was. So this event is kind of like it's like a log on Ethereum, right? We want to keep track of something, and we probably want to display that in our front end. So we could just query that directly using Scaffold-ETH. There's a hook for that. If you go to scaffold-eth.io and you go to interacting with your smart contract, there is a event history, and then there is also a watch contract event. So there's two ways you can get information. Lots of information, or if you want to just like watch all of the events that come off, you can also do that. So it's easy to get like small bits of data, but if you want to get like all of the events that happened since you deployed your dApp, maybe you want to get thousands of events, it's not effective to use something like this because it's going to be too slow, right? So we can take this event data, and as it gets emitted off of the blockchain right here, right, we can index it. That's what the graph is. It's an indexing protocol, right? So if we go to that subgraph folder and we go to the subgraph configuration, it's already predefined for us. This example comes with the network we care about and the address of the smart contract. It also comes with the concept of what are called entities. And again, we're not going to go too far down that rabbit hole, but it's how we want to store the data. And then we have this handler. And all of this stuff, it's three files. It's the configuration file, it's the schema, which is like how we store the data, and it's the handler, which is like how we process the data, which is runs an assembly script. You don't need to understand that stuff, but that's what a subgraph is. It's those three things created to process data. So if we want to write our own custom subgraph, we can, but we're just going to use the one that comes with this package for simplicity. We're not going to change the contract at all. We're just going to show how everything works. So Scaffold-ETH's done installing, so let's go up here. Let's go into the devcon folder. Let's do yarn start. Oh, sorry, yarn chain, sorry. Yarn chain, yarn start, and yarn deploy. Now, the difference with this package, because we have a third package that we're using, the subgraph package, we also want to have another window, right? So we still need our chain, we still need our front end. We want to do our deploys in this window. This last one is where we're going to simulate the graph in Docker, okay? Now, you don't need to know what Docker is, but Docker is basically a virtualization layer that allows you to run what are called containers. It's kind of like running virtual machines, but they're very, very small. And so we're going to use the the Docker's power to do that inside of what are called Docker containers. Again, you don't need to know that, but to do that, all we need to do is do yarn run -node. So that's going to, there's like a file that's on there called a Docker compose file that has all the configuration defined for creating a graph node on your machine and all of the infrastructure you need. So you need an IPFS node and you need a database, Postgres database. So it's pretty much all configured. You don't need to change anything. So we're doing that now. We're spinning up everything inside of Docker. So you need to have Docker installed. And that's just one example of one of the extensions. I think it's the most relevant, especially if you're going to hack at a hackathon and you want the graph bounty. Who doesn't like bounties, right? So use the graph one. So you know it's working, at least the graph infrastructure is set up when it says downloading latest blocks from Ethereum. So we have right here. So that basically means that the graph node, so graph node is the thing that processes data. It's what all the indexers run. It's a Rust-based implementation of like data indexing. That is all running when that says ready to download data's blocks. So we have our chain, we have our front end, we have the graph running. Now we just need to deploy our subgraph. So we already have a subgraph that's here. And this subgraph keeps track of all of the events that come off of the greeting. And when those events happen, it takes in the data types and it processes those over whatever network we want. So this is localhost. It puts those data type as objects, or I should say values, into a database in a certain data type, which are these. And it basically stores them and makes them available via GraphQL. So that's the power of the graph, is it creates an API for event data, which is super powerful. And it does that using assembly script mappings, right? And so if you come into this assembly script, we'll see that nothing's actually been generated yet. So we need to generate these types. We use assembly script with the graph, which is a subset of TypeScript. So it's kind of like TypeScript, but it's a little bit more simple. You can't do like imports of just standard TypeScript libraries. It needs to be an assembly script library. But it's super powerful in the sense that you can use the type safety of your imports. So we need to generate these. So let's go to Scaffold-ETH. So if we go to Scaffold-ETH, and let's go to the subgraph extension. By the way, how much time do I have? Anyone know? No? Like 30 minutes, 20 minutes, something like that? Okay. If I need to stop, just let me know. All right, so this subgraph tab here is this new tab we get, right? Because we're using this new repo. We've kind of templated in some code, and so now we can do some additional stuff. So you'll see on the bottom there's a very basic README that shows you how to get started. So to spin up the environment, you do yarn run node. I already did that. To create a subgraph, you run yarn local create. To deploy your subgraph, you do yarn local ship. To build out assets for your front end, you run yarn graph client build, because we use graph client. And then to clean up the database, if you need to, you can clean node. So it tells you exactly what you need to type. So let's do that. We don't have any data in our contracts. Maybe we make some, let's do some things real quick. Let's send some greetings. Let's do yo devcon and send. We don't have any funds. Let's get some value. All right, so Kevin was here. I'm just sending a couple things, so we have that. Thank you. Cool. So I've sent a couple things, but they're kind of like lost in the ethos of like Ethereum. Like, how do I get that data? Well, we could use the hook, right, to get that data. But if there's like thousands of events that have happened, well, it's going to be pretty clunky, right? So let's use the graph. Cool. So the next thing we need to do is we have the infrastructure set up to simulate the graph. We're going to do a yarn local-create, like this. Boom. So that's going to create like kind of like a skeleton environment for our subgraph. That's just like a very simple command. You need to type that once. Then we're going to actually like generate the code, build the subgraph, and then try to ship it with a few commands. So we do that by doing yard local ship. So what this does is it generates all the types for the subgraph. It builds the subgraph into a WASM module, right? Because we use WASM in the graph. And then it ships it to the graph node instance. And it puts all of the stuff into IPFS that it needs to, and it creates a GraphQL API endpoint for you, and it just does everything using the graph infrastructure. And then it asks you what version you want to use as well. So just like you'd have versions in your software, your subgraph evolves over time. You add a new event to your subgraph, then you add a new version, right? So let's do 0.0.1, hit enter. It's going to check if there's any errors in the code, right? If there was like something missing that was not properly generated, then it's going to give you an error. But it deployed successfully. We can see here that the graph is indexing data. Cool, let's go back. So first of all, we'll go to the subgraph tab, and there we go. We get the commands or the data here on the bottom. I'm kind of surprised it actually has the data already. If you make changes to your subgraph, you might have to regenerate the types, which is doing this. We use Graph Client, which Graph Client is like a front-end framework. It's similar to like Apollo or I forget the other one, Urkel. I like Graph Client because it's very simple. You can do some interesting things for like working with GraphQL. It's just a little bit more optimized, I think. So we use Graph Client, so there's this additional command that you might need to run to generate the types. But as you can see, the data is already there. And so if we look at that code real quick, let's go to the Next.js folder, app, subgraph. There's the main subgraph page, and you'll see here we create a table. So we do this greetings table, which is down here at the very bottom, right here. So we go to greetings table and go to the components of that greeting table. Here it is. So we use, using some state where we have this kind of query that we do by calling a get greeting document, which is probably somewhere in here. Here it is. It's just a GraphQL query. So if you're not familiar with GraphQL, GraphQL is like a query language that allows you to query exactly what you want in a very optimized way for front ends. And so we are using the graph for that. And so we're using this kind of custom query that gives us all of the data back in one single HTTP query, right? Instead of calling the RPC over and over and over and over and over again to get all the events, we're just doing it in one simple query. And we're also getting the greeting count and the address of that person that sent the greeting. So we're getting a lot of advanced data just with one query, right? And so, yeah, so what else do I want to show off real quick? So, and also it's going to give you this like URL, which is right here. So let's grab that real quick. Real quick, I want to show that off. So if we go to, boom, 12 minutes. I have enough time to actually probably go over the subgraph config if anyone's really interested, or I can answer questions about extensions. But let's first of all show this off. So this is called GraphIQL. GraphIQL is kind of like this way that you can like test your GraphQL configuration. So again, the graph uses GraphQL heavily, right? That's what we rely on for people being able to access the data in a reliable way. So if we click Explorer here on the left, and sorry, this might be hard to read, but we can see that there's these data objects that match what's in our schema. So these are kind of like what's in the database, basically. So if we look at this, the GraphQL configuration for the subgraph and go to the schema, these are going to match. So in our case, we have this greeter, and so we have greetings that happen, and then we have senders that send those greetings, and we kind of like build a database for all that stuff. And so all this data is what we're storing in Postgres and exposing via GraphQL, and that's what you're going to see over here is these entities. So if I want to get all the greetings, maybe I want to get like the first, I don't know, 1,000 for some reason, and I want to order them by when they were created, and I want to do it descending, and I want to skip over the first 100 for some reason, or maybe the first 1,000. You know, you have a lot of flexibility here. I want to know when they were created, what it was, the ID, and I want to know who sent it, what their address was, and how many they've sent. And then I can hit play, and I can get that data back. That's not working. Oh, because I skipped over. Let's not skip. There we go. So because I skipped the first 1,000, there was no data. But here we go. This is all my data. So this is a GraphQL query for, that I'm creating, and this is the response that I'm getting. So what we're parsing in our front end on over here, in here, is the data that's coming back from the JSON response over GraphQL. Cool. Hopefully that wasn't too fast. That was good. So I can also talk a little bit about the GraphQL configuration, but why don't we pause for a second and see if anyone has questions first about the extension system or about the graph or anything that I talked about right now so far. Any questions? Bueller? No? Okay, then let me talk about the GraphQL a little bit, the subgraph configuration a little bit more. Definitely, we would love for people to build cool extensions. So if you're in the crowd and you are working on a protocol that can take the Scaffold-ETH and create an extension for it, come talk to us. We'd love to hear what you want to build, and we can get it listed maybe on the docs. But yeah, please let us know if you think this extension system is useful, and if you would like to see any features or if you want to see a cool extension built, let me know. But let me talk a little bit more about the graph. So, because I think it's probably the most confusing thing of everything I just talked about. But I want to cover this part a little bit more because I didn't really go too much into this assembly script. One of the powerful things about the graph is it allows you to do some interesting things during the time that an event happens. So the primary way we get data is events. We also have the ability to do what are called substreams, where we can get like more block data. But in this case, the cool thing about assembly script is, again, it's a subset of TypeScript, so it's pretty easy to understand, but let's walk through it a little bit. So when we write our contract, just like Scaffold-ETH generates the ABI, right, to be able to interact with our contract, well, the same thing goes for the graph. It needs the ABI as well. So we take the ABI, and then we generate all of the assembly script types that we need and store them into these files. So in this case, there's a generated folder. It has the name of the contract, and then it has the schema types as well, so how we want to store the data. So this is kind of like how we want to read the data, and then this is how we want to write the data, right? So these are the types. This other thing here is what we want to do with the data. So we use the graph.ts package to, maybe we want to read in addresses from the thing and store them a certain way in TypeScript. We need this package, right? So that's why in this case we're using the big int package to do numbers, to use big ints. And so in this case, we only have one function that the contract is sending. And so we have this ability to, one event, the greeting change event. So we take in the event here as part of the function, right here, greeting change, and then we create a unique identifier for the values of that actual string. So we do that by converting it to a hex string. Then we try to load it in the database. So we try to see if it's available. If it's not available here, if it's the first person whoever has sent a greeting, we just create a new one, right? And then we actually set who that person that sent it is, what the timestamp was, and then we do here, this is where we use the big int package to actually set the value for the very first time as 1, right? So we do some interesting stuff where we're actually storing the greeting count off-chain, right? We're not storing it on-chain. So the graph is really good for that, because if you have stuff you want to process, like DeFi-related metrics, and you want to just store that in an easy-to-access way, that's where the graph is very powerful. And then if this person has come in and sent a greeting before, well, they'll actually have a count of 1 plus an additional 1. So it'll count that and add that too, right? And then the same thing goes for the greeting. We create an identifier for the greeting, create a new one using the string, the hex string. And then we set all those variables for the greeting, the sender, the premium, the value, the timestamp, and the transaction hash. And then here is where all that data gets saved. So it's kind of simple, and the cool thing about the graph, actually, if you use the CLI, it will generate all this stuff for you, so you don't need to write this stuff, but it's good to understand how it works. Cool. All right. So I know that part's probably a little complicated, but at least you guys get an idea of why you would use the extension, why you would use the graph extension, and yeah. Any questions at all? There's got to be at least one question. Come on. No? 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 Yes.
What is it that most excites you about this project and the new things that it enables?
Scaffold-ETH or the graph?
The graph, the graph.
The graph. Well, the graph is great because it really allows you to improve the usability of the data from the blockchain, and so you can build some interesting stuff. I think what I'm most excited about is the advancements that we're making in indexing with like substreams. And yeah, just the network's the network is very secure, distributed, decentralized, and we're like sticking very much to that ethos, right? Where we believe that decentralized is super important. And so about, I don't know, it was 6 months ago, maybe not that long, we used to have a hosted service. We've completely moved away from that, and everything is on the decentralized network. And we're moving to continue that and focus on decentralization. So.
Thank you.
Yep, thank you. Cool, we got 4 minutes. Any other questions? Yep, back there. Let's get you a mic. Back there, green sweatshirt.
Okay, so first one, maybe it's because I don't know the graph and so on, but you can run mutations like in GraphQL, or it's only for indexing data and fetch from the blockchain?
Sorry, I missed the first part. Can you say it again?
Yeah, in GraphQL you can do query and mutations, and here in the graph you are able to run mutations in the same way, or
You
it's
say
only for
computations?
Yeah.
Yes.
Okay.
Yeah. So you can essentially do like in there. I mean, I'm doing like a plus, or I'm just adding some stuff. There's time series data you can do with the graph, where you can like have like something happen over a certain period of time and aggregate. So there's some stuff you can do automatically with some base stuff, but yeah, it's more, yeah, you can do computation. You just can't do like, it's not an oracle where you could go out and like fetch some information and get that back. It's just stuff that you can do locally inside of assembly script and process and store.
Okay, and the second one, how much is auto-generated by the ABI? Is only the types from the schema, or also in the handler we are auto-generating on?
Yeah, so if you use, so that's a good question. So the thing is, it won't generate it won't generate all of the assembly script code for you. It will just generate the types. But the CLI, like the graph CLI, if you go to thegraph.com and install the CLI, that will read in all of the types and then build out a very basic kind of one for you.
Okay, thank you.
Yeah, good question. Cool. Any other questions? No? Awesome, cool. Thank you guys so much for coming. We're going to be here. We might take a small lunch break, I think, soon, and we will be back here later. So thank you so much, guys. Appreciate you.
I think they do have a Q&A here where you can scan this QR code and ask questions. So if anybody wants to, you can scan this QR code and it's going to show up right here on the screen. So feel free to ask more questions here. But we're here all day, and if you find any of these black shirts, you can ask any questions. I think now we're going to take a break, though, right? It's a lunch break time. Is that right? If the QA shows up, we'll answer it. Yep. If questions show up here, we will answer them. But yeah, don't feel too much stress to do that. The key is